Okay, for this function, g of x equals the cube root of x minus 3 plus 2, my first step is to identify the points of accuracy. Looking at this, my points of accuracy will be located at -5, comma 0, at 2, comma 1, at 3, comma 2, and I have another point of accuracy at 4, comma 3. Now, out of these 4 points of accuracy, my point 3, comma 2 will be my point of inflection. Let's go ahead and box that in, and this will be the turning point. Let's go ahead and plot the points. We have -5, comma 0 located right here. We have 2, comma 1 located right here. We have 3, comma 2 located right there. Then 4, comma 3 located here. So based on the information that we're seeing, we're going to sketch the following graph. So we're going to start like this, keep going, and then as we get closer and closer to that inflection point, we're going to turn and continue like this. Now, this is just a rough sketch. It doesn't have to look perfect. It's a rough sketch. And for this particular function, the transformation will be the following. We will g of x is translated right 3 units and up 2 units. The axis of symmetry is based on the x-coordinate of the point of inflection. In this case scenario, x is equal to +3. For the domain of my function, it's going to be from -infinity to +infinity. Keep in mind that the domain and the range will be both -infinity to +infinity for the cube root function. And this function is a positive, so hence it's an increasing function. And let's go ahead and move on to the second question. For the second one, we have g of x is equal to the cube root of x plus 4. My first step is to identify the transformation that's occurring. In this case scenario, the transformation will indicate that g of x is translated up 4 units. Then I will identify the points of accuracy. In this particular function, I have -8, comma 2. I have -1, comma +3. I have the point of inflection at 0, comma 4. Let's go ahead and box it so that mentally we know that we have to turn. We have another point of accuracy located at 1, comma 5. And our final point of accuracy located at 8, comma 6. Let's go ahead and plot these points. So we have a point of accuracy at at -8, comma +2. We have another point of accuracy at -1, comma 3. The point of inflection at 0, comma 4. Then 1, comma 5. And finally 8, comma 6. From there, we will then connect these points, turn on the inflection point, and go towards the right-hand side. So my axis of symmetry is based on the x-coordinate, will be x is equal to 0. My domain will be from -infinity to +infinity. My range will also be from -infinity to +infinity. And this function will be considered to be increasing. It's a positive function, so it's increasing. Let's go to the third question. For the third question, we have g of x is equal to 5 times the cube root of x plus 3. My first step is to identify the transformation. Looking at this function, the transformation indicates that g of x is vertically stretched. You can also refer to this as expanded by 5 and translated points. We have a point of accuracy located at -8, comma, -7. We have another point of accuracy located at -1, comma, -2. We have another point of accuracy located at 0, comma, 3. And this is going to be, then we have our 0, comma, 3 is the point of inflection. Go ahead and box that in. And 1, comma, +8. From there, we're going to plot the points. Now, this one can be a little bit tricky. You do have to graph it on your calculator so you can see the full picture of this. But we have a point of accuracy located at -8, comma, -7 right here. At -1, comma, -2 right there. At 0, comma, 3 right there. At 1, comma, 8 right here. And when you graph this, it's going to look a little bit strange. So look right here. So it's going to go like this. And as we're getting close to that point of inflection right there, we're going to turn and go in that direction. So that's my graph right there. Okay, now for the axis of symmetry, it's going to be located at x is equal to 0. The domain will be from -infinity to +infinity. The range will be from -infinity to +infinity as well. And this function will be considered to be increasing. Let's go to the next question. For question number 4, you have g of x is equal to the cube root of x minus 4 plus 1. Your first step is to identify the transformation. In this case scenario, g of x is translated 4 units to the right and up 1 unit. From there, we will then identify the points of accuracy. In this particular case scenario, I have a point of accuracy located at -4, comma, -1, at 3, comma, 0. Oops, and my apologies. Let me just go back to question number 3. Yeah, okay. All right. And from there, another point of accuracy is located at 4, comma, 1. And at 5, comma, 2, in which the point of inflection will be at 4, comma, 1. From there, let's go ahead and plot our points. So on the right-hand side, we begin by plotting -4, comma, -1 right here, 3, comma, 0 right there, 4, comma, 1 right there, and 5, comma, 2 right there. And from there, let's go ahead and connect the points. So we go in this direction, we go upwards, and then at the point of inflection at 4, comma, 1, that's where we turn, and we go to the right-hand side. Okay, and that's our graph. Let's continue. For the axis of symmetry, it's going to be located at x equals 4. The domain will be from -infinity to +infinity for both the domain and the range. And this function will be considered to be increasing. Let's move on to the next one. For the next one, we have y equals the cube root of x plus 1. In this particular question, my first step is to identify the transformation. So looking at this, y is translated left 1 unit. For the points of accuracy, I have them located at -2, comma, -1, at -1, comma, 0, at 0, comma, 1, and at 7, comma, 2, in which the point of inflection is located at -1, comma, 0. From there, let's go ahead and plot the points. We have one at -2, comma, -1, at -1, comma, 0, at 0, comma, 1, and at 7, comma, 2. From there, let's go ahead and connect the points. We have something that looks like this. We go up and turn at the point of inflection, and we go in this direction. Okay, then the axis of symmetry is located at x is equal to -1. The domain and the range will be from -infinity to +infinity. And this function will be considered to be increasing. It's a positive function. Let's move on to the last graphing question. For the last one, we have g of x is equal to negative cube root of x minus 1 plus 1. My first step is to identify the transformation. For this one, g of x is reflected over the x-axis and translated right 1 unit and up 1 unit. For the points of accuracy, I have them located at -7, 3, at 0, 2, at 1, 1, and at 2, 0, in which the point 1, 1 will be the point of inflection. From there, let's go ahead and plot these points. At -7, 3 should be located right here. Oops, wrong spot. There we go. And at 0, 2, right there, 1, 1, 2, 0. Okay, so we have something that looks like this. We begin at the very top, go downwards, and as we're getting to that 1, 1 right there, the point of inflection, we turn and we go in this direction. There we go. Okay, now for the axis of symmetry, it's located at x is equal to the x coordinate 1. The domain and the range will be from -infinity to +infinity. The range will be from -infinity to +infinity as well. And this function will be considered to be decreasing. Why? Because there is a negative symbol right there. Let's go ahead and continue to problem number 7. Now, for this question type, you're told to write the cube root function of the graph that's given to you. So looking at this one, guys, what do we notice? Compared to the parent function, we notice that the parent function begins at 0, 0 at the origin, and this graph was what? Translated downwards by 4 units. So we don't see any shift any shift to the left nor to the right. So hence, the function will be the cube root of x and then -4 outside the radical symbol. From there, let's move on to the graph for b. The graph for b, what do we notice? We notice that when compared to the original, the parent function at 0, 0, this graph was shifted to the left 3 units, right? This is the point of inflection right there at -3, -1. So be careful because the grid right here is going by 2, so half the square will be 1. Okay, so looking at this, my equation will be the cube root of x, and we shift it to the left by 3 units, so hence we have +3, and then we went down by 1, so -1, and that's my equation. From there, let's move on to the next question type, which is when given a description, provide the function. For the first one, we have f is reflected over the x-axis, so for this one we have let's write down g of x is equal to negative, right, cube root of x, and it's translated up 5 units, correct? So if it's translated up 5 units, we have the +5 outside the radical. Then it's shifted horizontally to the right by 3 units. So hence we have -3 inside the radical. For the next one, we have f is translated left 7 units and up 2 units. So I have g of x is equal to the square root of x. Then we notice that this is what? Translated left 7 units. So hence we have a +7 inside the radical, the cube root, my apologies. And then up 2 units. So hence we have +2 outside the radical. Then down below, we have f is translated horizontally to the left 3 units. So let's write this down. We have g of x is equal to the cube root of x. This is shifted to the left, so hence we have +3. And then vertically down by 4 units, so -4 outside the cube root. For the next question, we have f is vertically stretched by 2. So we have g of x is equal to 2, then times the cube root of x. This then says what? Then translated left 4 units, so hence we have plus 4 inside the cube root. And it indicates that it's going to be down 1 unit, so minus 1 outside the cube root. For the next one, we have g of x, or excuse me, f is vertically compressed by 1/3, so we have 1/3 outside, times the cube root of x, and then it's translated to the left 1 unit, so plus 1, and then down 3 units, so minus 3 outside the cube root.